Hello, hello, and good evening. Today I have my colleague Martina Kraus with me, and together we will hack an Angular application. Hi, Martina.
Hi Manfred, thanks for having me. How are you?
Yeah, I'm fine. I'm really fine. I'm really looking forward to our live hacking. I've seen the agenda before, and it seems to be a really nice agenda with a lot of attack strategies. So I'm really keen of it. Do you want to introduce yourself a bit and why you like to hack applications?
Yeah, of course, sure. Thank you. So basically, I studied computer science. I'm a developer. I started as a developer. I've been into Angular for like a long, long time since the beginning, the good old Angular JS times. And after like a couple of years, I figure out this security thing. This is something I really, really like and I find really intriguing, like how to protect my website, of course, how to figure out, because it's always like a competition, like having some prevention measurements, and of course, like the hackers, which are getting more and more creative, and the tools, which are getting faster and better as well. And I like this kind of competition is always something new. You always have to be creative in how to defend yourself. And of course, I love talking, so I also love a lot to consult all kinds of developers, front end and back end, to help them protect basically their web applications. For that, I also got recognized as a Google Developer Expert in Angular and Identity. And also, for quite some time now, I'm an OWASP member. Like OWASP is
Wow, that's
open
cool.
world. Yeah, absolutely. I mean, you can join them, and then you can also create some standards, help to develop some kind of standards inside the web browser, how to protect cookies and things like that. And it's been really great stuff and really intriguing. And actually today we will get inside some OWASP project I helped developing with, since it's an Angular application, and we will actually hack this application as well. And then I also will show some countermeasures how we could have done protecting this application, of course, better.
That sounds awesome. That really sounds awesome. A lot of live coding or live
Yeah.
hacking, lots of code. I really look forward to it. So perhaps we are activating your screen and yeah, let's
Yes.
go on with hacking this juice shop.
Absolutely. I mean, maybe some of you already heard the Tool Shop. It's a great application. It's an Angular application, and it was created by Björn Kimmich. He's also an OWASP member, and he thought, let's create an application who is full of security issues. And you might think, yes, but I'm using Angular, and Angular has, of course, a lot of protection measurement itself. And indeed, Angular is one of the most secure front-end framework besides others. But there are still some things we need to consider, and of course, we need to do. And I just want to show you a couple of those. And I don't know, let's just dig right in. And what's the most common ones? I mean, when we're talking about SBAs, single page applications, we have a lot of JavaScript. So, well, Manfred, what do you think? What is, when it comes to JavaScript, what is the most common attack you could do on a website?
Well, I think cross-site scripting is really common. I think it's on top three in the OWASP top 10.
Absolutely right. JavaScript injection attacks, also called XSS and cross-site scripting attacks. And for that, we might research a little bit on the website. So we might want to figure out, hey, where could be an input field, for instance, is a common attack vendor. We might just want to enter some, well, JavaScript code. And I just logged in myself. So I created already an account with an email address, and I just logged in myself. And here, one thing that immediately pops into our mind is like a global search field. So here we can maybe search for some banana or whatnot. And well, we see this query here, this global search field. the word that is written here immediately gets written there as well. And additionally, it's also inside a query parameter. So actually this query parameter also tells, or we can also manipulate this query parameter to have it reflected inside the search results. So if you maybe change something to Apple over here, then we find the word over here as well. So we have already different kind of attack vendors. We might could just try to, well, insert some JavaScript. Well, a tag like an HTML tag, which always we are using when we want to insert some JavaScript, is of course the good old script tag. So let's try this first. I just put in a script tag with some alert. Let's just try this. Okay, we see nothing happened. So luckily, seems like Angular just doesn't allow us to do this, or there is some sanitizing process or input encoding, something luckily protects us from having executed this JavaScript. But the thing is, we now, of course, might have a filter for a script tag, but what is the one tag every kind of web developer actually hates? Of
Don't
course,
know. The marquee
it is.
tag.
Yes, yeah, absolutely. But when it comes to maybe embedding one website into
Oh, yeah,
another,
yeah. Now I feel
yeah.
you. It's
So
the
that
iframe, isn't it?
absolutely, absolutely right. And usually we allow to insert an iframe inside our HTML because why not? Why not? Sometimes we actually need to allow it because we want to have some HTML website embedded in our own. So usually the iframe is not filtered out. So with the iframe, we can actually even execute JavaScript.
Oh, wow.
And here
That's funny.
we have our first cross-site scripting attack, which is really scary, isn't it, already?
Yeah, yeah.
And maybe you think right now, yes, awesome, congratulations, you executed an XSS attack on your own website because you entered some string in your global search field. Yes, but you remember, we actually can do the same with inserting inside the query parameter. So I can just copy this and I could send this URL now to you, Manfred, and you click on it, and then this attack happens on your website as well if you open your choose shop with your account.
That means you could grab some sensitive data I'm typing into it, and yeah, then you can use it.
Absolutely. Good that you mention it. I mean, now we can execute, XSS just to be able to execute JavaScript code isn't really harmful. But what we can do actually with that, well, a lot. We can steal credentials. So maybe let's start with something really easy. Let's think that you might have a token-based authentication mechanism. You create, maybe you have some kind of identity provider like Zero, like Azure Enter-ID or AWS Identity, whatnot. And of course, Manfred, just hypothetically, if you would create now an OAuth OIDC client SDK for Angular applications, just hypothetically, of course,
Yeah, yeah.
it would be open source, right? So one could easily see how you store maybe the token and where. And maybe, which is completely okay, you would say, okay, default, the token should be stored in my local storage, which is fine to do so, at least we think. Because storing the token inside the local storage, we actually easily can get it out of there. So for instance, I just have access to my local storage, to my local storage, if I am able to actually writing it. And then I can have this API get item. And since you have an open source library, you can just open GitHub and find the key on which the value, the JWT token it is. I mean, Manfred, do you remember the key of where you actually store the Bearer token?
I'm
When
not sure. Perhaps it's token or bearer token or access token or ID token, something like this.
Absolutely right. I mean, the most common thing is to have it inside token.
Here
And
it is.
and apparently also Choose Shop stores the token, the Bearer token, inside the local storage. So having this combined together with an XSS attack, well, just try out another string over here. Let's try out to not alert something, but I have again an iframe, and now I alert the token I actually get from, well, the local storage. And here it is, our token.
Oh, wow.
Okay, this is exactly the token. So what would be the last step of actually stealing the credentials?
Perhaps a hyperlink where you send it over to your own domain to a dynamic website that grabs this token out of a parameter and stores it somewhere.
Absolutely. I mean, I make it a little bit easier even. I have here a running attacker website. It's on localhost 4000. And well, let's just use the fetch API to send and request to my attacker website.
Oh, cool.
So what I do is I have here another great string where I actually do exactly that. I use the fetch API. I give in my localhost 4000, and as in a query parameter, because I just implemented my attacker website like this, well, I will add the token I steal out of the local storage. Let's do this. I just entered it and we see it here in the query parameter. And if I refresh my attacker website, here's the token. Here is the
Oh,
access
wow.
token.
Wow. And this was really easy. It was really easy to get this token here.
Absolutely. So whenever you're trying to figure out where to store a token, you might should not consider the local and session storage, since as soon as there is a kind of an XSS attack, you can just easily steal the token. And as I mentioned, this URL with this query parameter, I can just easily send around. I mean, Manfred, I know you would never ever click on this URL because you apparently see that inside this
Never.
query parameter, definitely you see that there's something really strange going on. But we have so many bit.ly tiny URLs. I mean, have you seen what LinkedIn is even doing nowadays? They're not displaying the URLs as they are. They converting it also to something like a LinkedIn special URL.
Okay.
It's really fun to watch. They also, like, I don't know if they're using tiny URL or they are converting it that you actually don't know what you're clicking on. It's a little bit scary and strange just to observe. So you can't even know what's behind the URL. And of course, a query parameter could just be easily look like this, but you never see it. It's a typical kind of social engineering where I just send a tiny URL link to someone and then, well, an XSS attack is executed.
Wow. Well,
How
I know that something like this is possible, but seeing this now in this example is scary even though. So I really hope that this is making a lot of people sensitive, that they should think about where to store their tokens.
Absolutely right. I mean, I will just talk about prevention measures in a bit. I
Hmm.
just want to talk a little bit about another storage option. I mean, we have local, we have session storage. Of course, you could use an index DB to store maybe the token, but there's another option developers tend to avoid, but maybe they shouldn't. Do you remember maybe, Manfred, what could be another storing option for tokens?
Perhaps cookies.
Cookies, absolutely right. So we can have a look at the cookie. You can see that here in the application. And here we also actually see that here we have the token stored in the local storage.
Hmm.
But since this application is a little bit messed up, it's also stored inside a cookie. Actually, we have a couple of cookies stored here, like a session and something that stores the progress of my hacking and things like that. So don't mind. Then the resting cookie we want to take a look at is the token cookie, basically. So it's just a cookie with a key value part, token, and the token we've already saw.
Hmm.
Okay, so this is not so easily accessible throughout JavaScript, is it? I have to tell you it is, since
It should be, I guess, because it's not HTTP only.
absolutely right. I mean, I will get back to HTTP only in a sec. So if you write document.cookie, you just
Hmm.
get the whole cookie. So again, of course, we could do exactly the same again and again. Instead of accessing the local storage, we could now just have the same fetch request or an alert for document cookie, and then we're getting, of course, the whole, well, all the cookies set on this website.
Hmm.
But the cool thing, the really cool thing, and you mentioned it already about cookies, is that we can protect them so incredible easily from JavaScript access. And here for that, we have a couple of attributes. We have the HTTP only, you mentioned already, Manfred. We have something called secure and others. I will explain a couple of them soon. So you mentioned HTTP only. So you know already what it does, Manfred? HTTP only?
Yeah, so if this flag is set, you cannot access it via JavaScript.
Yes, easily said and exactly that. So if I set this HTTP only flag over here and, for instance, try to access the whole cookie again, we see actually the token cookie is missing over here because it has the HTTP only flag, which is like now it's impossible basically to steal the cookie throughout JavaScript. So this is one of the best thing about cookie attributes. Do you know other attributes? Do you know what secure does?
Yeah, so it only allows to use it if you have an HTTP connection, I guess.
Exactly, like a secure, like a TLS connection.
Hmm.
So the cookie will just be sent to the server if throughout there's a successfully TLS connection. And I highly recommend setting these two attributes to like all the cookies you want to set, especially of course session cookies. Yes, we could be really lucky to have that, but unfortunately, there are other attacks who we can easily steal this cookie. But first, I want to show some prevention measurements when it comes to XSS attacks. And when it comes to XSS attacks, I recommend two countermeasures. First, of course, output encoding. Use some kind of sanitization. I mean, we are really lucky as an Angular developer because whenever we use the Angular API, the DOM sanitizer of Angular itself just sanitize it. And whenever there's something strange and really, like if you try to do something with inner HTML to add directly into the DOM of our app, Angular will say, not at all. Definitely, you shall not pass. Definitely not. I will not render this, which is great. Of course, Manfred, you know we can inject the DOM sanitizer, and then we can bypass this security check and still allow it. But for that, I highly recommend the DOM purifier. Have you heard of the DOM purifier before?
I don't think so.
The DOM purifier is like a sanitizer, which you can use even if you don't want to use a framework, like let's call it plain JavaScript, often called vanilla JavaScript. The DOM purifier just sanitizes everything for you. For instance, I don't know, Manfred, do you already had an Angular application where you injected the DOM sanitizer on purpose to actually bypass the sanitization process? Can you remember an example, or have you ever done that?
I'm not completely sure, but I think when we want to display HTML or Markdown, then we need to do something like this.
Absolutely right. This is a great example, actually. And what we did in a project, we needed to have some translations added in, like with NGX translate and internationalization, and the translation string itself needed to contain HTML. And so we needed to add it throughout an inner HTML property binding. And for that, we needed to definitely bypass this sanitizer. But if you do that, I recommend to add then still the sanitization process throughout, for instance, DOM purifier. DOM purifier is a great, incredible library, which it's open source. You can just dig into it, and you can just like use it for sanitization. So this is like what we usually call first line of defense. The second line of defense is often an HTTP security header. And this is often the content security policy header. Just 2 words on it, and I will actually show this CSP also in action. The CSP basically is just a header and response header, which I could just tell of, I just want to have JavaScript code executed that is from my own origin, or from this origin, from this URL. You can add some other stuff in here, which allows inline JavaScript to be executed and whatnot. But basically, you could exactly tell the web browser which kind of content should be executed. This goes from JavaScript code over stylings to even images. Let's see this a little bit in action. So I will just shortly go to another website and to my profile page. And here I will execute another, basically, XSS attack. So again, I will try to maybe inject in this input field, another JavaScript attack. Let's do that. Okay, nothing happened, but we saw maybe there wasn't really a sanitization process, but someone implemented his or her own, sanitizing logic, which just contained, maybe removed the opening script tag and the first character after that, something like that. And we can maybe even validate that. We could just do something like, okay, if this is the validation logic, we can insert a string which contains a first script tag and the character after it, And we see if this gets removed, then we still have our script that will be executed. So if we do that, it actually got removed, but JavaScript is still not be executed. Okay, so let's go inside our browser console. And here we see CSP in action, which tells us that it refuses to execute this kind of inline script because it violates some content security policy, which is in this case script source self unsafe eval. So I'm not allowed to execute inline JavaScript code over here, which is great, which is such a great measurement to protect yourself against XSS. But also additionally, you are also able to add even more rules, and you can also add, for instance, a rule that just your own inserted inline JavaScript is allowed to be executed.
I like it.
I love content security policies, and for instance, let's do this once more. It's just a response header. So here we see the content security policy, and we see a couple of directives like image source. Here's the source, script source directive. It's great. I really highly recommend to take a look into this. So leaving a little bit the section of XSS attacks, we want to dig a little bit into this, can the cookie still be stolen? And of course, we talked about JavaScript injection. When you think of cookies, do you think of another attack which cookies actually exposes or like open the door for?
Yeah, so cross-site request forgery is also always a huge topic.
Yes, unfortunately, yes. So cross-site request forgery is like also unfortunately most common attack, which uses the cookie-based authentication as their favor. So what they're usually doing is, yes, cool, I logged myself in here in a website. I'm logged in apparently, and as already seen, I have a cookie set, which is my token basically. So what if I could trick the browser sending a request to localhost 3000, like to the Choose Shop backend API, and editing something, and basically the browser does what the browser does, it sets the cookie. Because the browser, when it sees, oh, there's a request, I have a cookie for this request, because here's the domain, and I have a cookie for this request, I will set it. I'm a good browser, I will do that, I'm awesome. Yes, and so let's go to another website. I have another website running. It's my cute cat website. This is my little cat. Every single time when I stand up and get something from the kitchen, I see this picture because he always wants to sit there and just looks at me. You're not allowed to sit here again. Yes.
I like
Which is
Raupi.
Ralphie. So I mean, this is so cute. I can just send it to someone, but what the person not knows that I might, as soon as the person, my victim basically opens up this web page, behind the scenes, I actually sent another request to localhost 3000. And this is really easy to implement. So this is basically my index.html, where I have this little cat picture of my little cute kitty, well, and now what I insert is a form tag. This form tag, what it does is nothing really special. It's a form tag, and which is sending to a backend API of my profile. So I want to change something, some user data apparently, a post method. And here I have some hidden input fields, so the person, my victim, would never ever see this input field because it's hidden. And not really scary, but I changed the username to some other value. Okay, this okay. And after that, I insert a script tag which submits the form for me. So
Hmm.
immediately when this website gets rendered, it will basically, yeah, executes this form. Okay, I insert this form and let me shortly restart the web server that it gets updated. And what now happens, if I refresh, the browser does something really crazy. Do you know, can you imagine what happened right now? I'm the browser redirected me now to my profile page, and we can see that the username here has now CSRF attack. This is the
Yeah.
browser behavior. So what happened? Do you know?
Yeah. So I guess the browser not only opens this website, but also forwarded the already existing cookie to the backend. And so the username was changed in your case to CSRF attack.
Exactly. But I mean, to be honest, if I would send you an URL, like like any kind of URL, and then you open it, and out of the sudden you get redirected to your profile page, you will get really suspicious, right?
Yeah.
But
Hmm.
this is strange. So I mean, and I immediately see that something wrong with my username, so I will immediately change it back. Or it could be not my username, it could be my password, of course. So this attack isn't really ready yet to be really good and good to be executed.
Hmm.
But well, once again, what is the worst tag of the whole world?
The iframe.
It's iframe. Absolutely. So what I insert here is an iframe tag, a hidden iframe to be clear.
Hmm.
And well, I want to have this action executed inside the iframe. So the browser, after submitting the form successfully, doesn't redirect me to my profile basically, but in the hidden iframe instead. So what I just need to do is setting a target here in this form tag, and having it called hidden frame, like the name over here. Let me shortly, if I'm not having a typo, yes, perfect. Well, and let's do this once again. I sent you an URL and you will
Hmm.
just see this. You will see my cute cat, you will laugh about this cat for 30 minutes. And within this range of 30 minutes, I already hacked your account and did a lot of stuff because I changed your password and your username, and then I did a lot of stuff. And well, this is really scary. I mean, you can see it when you open the network tab, then you actually
Hmm.
see that something like a request was sent behind the scenes. And you can also see that in the request header, the cookie, actually all cookies of localhost 3000 have been sent. Also the token, which gives me the privilege to change password, username, all the user data. And all the victim is doing, watching my cute cat inside this web browser.
Wow, yeah, that's really scary.
Absolutely.
I
And
almost
I'm
forgot about the target tag to target another frame, but of course, this was what it was originally about. Not just target underscore blank, but target this or that frame, or in this case, iframe, which makes this attack really simple. You don't need a lot of JavaScript for this.
absolutely. And that's why it's also always not recommended to just click on any kind of link. Like just like if any person's trying to force you clicking a URL, it maybe you should first check all your session cookies if you're logged out properly,
Hmm.
that they don't exist anymore. Then you, or maybe you just, you can of course use some web browser, no cookie at all is inserted there, like a web browser you never been using, like Internet Explorer. You're never using Internet Explorer, so maybe you can open this one and insert the URL you've just been sent. So how we can protect ourselves from that? Because I mean, we got HTTP only and secure already as like a protection measurement of that the cookie isn't accessed through JavaScript, and we have like secure that the cookies is only just sent through HTTPS. Well, to be fair, this would have helped already here because apparently this is not a secure TLS connection. So if we would have said that, then yes, the cookie wouldn't have been sent. But there's another cookie attribute, which I highly recommend always to use, and it's the cookie attribute same site.
Hmm.
It's not so common. People know maybe HTTP only and secure, but same site they're always afraid of a little bit. What same site does, you can set a couple of values. For instance, you can set a strict value. I guess it's written in a couple cases. Yes, yeah, in upper cases. So what strict does in this context, it just allows this cookie to be sent with if the domain over here matches exactly the domain you entered here in the address bar. This must be same site. That's why it's called same site strict. Just if I'm really actually at the site where the cookie has been created from, then the cookie is sent. But here on this example, I'm not on the same site because this is apparently localhost 3001, or I mean, yes, localhost is actually the same site, but leave this a little bit apart. Let's imagine that this really is a cross site. It's a really different site. If this could be like mycutekittycat.com is definitely a different site than localhost 3000.
Hmm.
And for that, the cookie would have not been sent, which is great. So another recommendation of mine, use also beside HTTP only and secure the same site strict flag. Which basically is, I mean, we have a couple of other counter measurements. Actually, Angular has a built-in mechanism to protecting ourselves from these kind of so-called CSRF attacks, like cross-site request forgery attacks. Because Angular automatically sets a custom HTTP header. And setting a custom HTTP header wouldn't allow in this kind of scenario that the server actually does something, because the server would basically assume that there is an HTTP header within the form request. And if I'm just using the form of a browser for executing this kind of attack, apparently I'm not influencing some kind of request header, but the server expects it. And that's why I can't change my username in this scenario. I would again need to insert some JavaScript to maybe throughout the fetch API to actually try to simulate this kind of custom request header, but this is of course a little bit more effort, and you need to have again an XSS attack found before. And this, to do this, you don't have to do basically anything. You just enable the HTTP client of Angular to do that, which is amazing. So Angular has a built-in countermeasure against CSRF attacks, which is great. That's why I love Angular, and no other front-end framework has this kind of built-in measurement against CSRF attacks. And that's why I love Angular. Cool. Let's think of some other attacks. When we are still into injection attacks, I mean, nowadays we are using so many microservices, and of course we are using many different kind of databases. So another injection attack could be a typical SQL injection attack. So let's try to execute an SQL injection attack. For that, I just shortly log myself out. And the best way to figure out if behind the scenes in the backend, maybe this is a MariaDB. I don't know, what is your favorite SQL database?
Well, in former days, I did a lot with SQL Server and Oracle. Nowadays, I also do a lot with MySQL.
Absolutely. In the project I did the last time, we used SQLite, Postgres as well, and a couple of like NoSQL databases. But the best way to figure out what kind of SQL database it's been used is to provoke an error. And we could maybe do that. I mean, well, when we come to scary things and characters, could you imagine what is the most scariest character of an SQL database? Maybe. I mean, there are a couple of those. It's an unfair question, but maybe you guess already the one I'm searching for.
Oh, perhaps something like, Hochkomma. How do you call it?
Yes, single quote.
Single quote,
Absolutely.
yeah.
A single quote, exactly the one I referred to. So just use the single quote and password. Let's enter something and let's open already the browser console that we already see what maybe happens. Let's log in. Ah, perfect. We have an error. That's amazing. Let's see what the payload of this error is, shall we? So the response,
Okay. Nice.
it's an SQLite error. So why we are doing this, why we want to figure out what kind of SQL database we have behind the scenes. I mean, I'm pretty sure you know as well, different SQL databases have different kind of query languages or different character encoding or different kind of keywords sometimes, how SQL query should be executed. I mean, as always, we have a standard, but a lot of things implementing the standard differently, apparently. So yes, so for that, we figure out, it's an SQLite error. And we can actually also figure out how maybe the login mechanism is working, like something select star asterisk. No, is it asterisk called in English? The star
I
over
think
here.
so, yeah, I think so.
Yeah. Asterisk from user's email. Here is like the single quote and password. Okay, I don't know what this password is actually, where this password is actually coming from, but there's already some password inside. So what we could do now, because we see that the character over here is immediately inserted inside this email and like immediately forwarded to the database, which is like a jackpot for each and every hacker wanting to execute an SQL injection. So what we could do is to type something like again and single quote using some SQL statements like or, and now I insert a value that is always true, like with always true, and something like 1 equals 1 is always true. In SQL, 1 equal sign is like an equal. It's not like JavaScript where we have triple or double equals. Basically, in SQL, 1 equal sign is enough to compare two things. And then we use like comments, like the double dash dash inserts like a comment inside SQL. So what happens right now is this string we have over here will immediately insert it inside this email over here. So we actually closing the email. The email is empty, and then we inserting something like or 1 equal 1. And with a double dash, we commenting out everything after it.
Hmm.
And let's see what happens if I log in with this. I was able to be logged in, and most of the times we are the admin, because sometimes if the default user role of an SQL database, sometimes it's just the admin. And that's why we are now logged in as the admin, which is, yeah, I'm devastated to even demonstrate it. I can't find any kind of words how scary that basically is. So the thing, of course, here is also again encoding. Like just encode everything. I mean, can you think of an prevention measurement in the back end, but maybe the back end could have done a little bit better to prevent this kind of SQL injection?
Yeah, I think we need to encode the strings, and a lot of database drivers or data access libraries have an API for this, or do this automatically if you just not concatenate strings, but give them a parameters object or something like this.
Absolutely. I mean, of course, one would say, yes, I mean, we have C Sharp, we have our entity framework in .NET C Sharp, we have Hibernate in Java. We are not concatenating strings. But well, there's still so many PHP applications out there which are exactly doing this, and which basically telling me it's too costly to change the whole backend system to change this. So, well, yes, nevertheless, as Manfred said, just encode everything, and of course, never trust the front end. It's not enough that just the front end is actually doing the work and encoding and sanitizing everything. Also do that in the back end. There, as Manfred mentioned, there are so many libraries, NuGet packages, Maven packages out there where you can easily basically do that. So cool, but we are in the admin section. We should maybe figure out where the admin area is, the admin panel. So here's a menu. I don't see something like this over here. So we could just guess it. And this is also sometimes hackers are doing. They have like kind of a research phase before, where they're trying to get so many informations about your website before actually executing the attack. So what we could do is maybe doing something like /admin over here. Okay, it didn't work. That's
Okay.
sad. So maybe it's root. That also didn't work. So this is sad. Where could we figure out this? And then, of course, I remember it's JavaScript. Everything is already inside the front end. So
Oh, yeah.
let's dig into the source code. So, I mean, we have now the source over here. So, for instance, when we have here the main.js, this is here entry on the stride, this is an Angular application. So all the information might lay somewhere here. So Manfred, I want to figure out how maybe like there must be some kind of configuration file where all the routes are defined. I mean, you are one of the most Angular experts I know. So what kind of string would you search for to figure out where the where the router config maybe to jump to the router config?
Yeah, something like roots, I guess, or component, or path, or just app.roots, I guess.
Yeah, let's try path.
Router
Pa
module or provide routes, something like this.
Yes, absolutely. You can just try to figure out all of those. I just take the one of those you said, and it's path. Here we have
Okay, good.
all the paths, objects. Well, I mean, we have a lot of those, but we have already seen the one of course, I'm looking for. It's administration. So we were close. I tried slash admin, but we were close. Administration.
Mhm.
And for that, I also highly recommend some kind of lazy loading strategies to capsulate it, to not immediately load all the configured routes at once. I'm pretty sure Manfred can tell you a lot about lazy loading and how to do that. He wrote a whole book for Angular, which I
Get
actually
it?
also have. Yeah, yeah. So I'm pretty sure you can watch any kind of talk of him where he talks about lazy loading. So just to not have all the routes immediately displayed over here. But well, yes, now as we have it, let's just use it, and we go to the administration section. Awesome. So
Hmm.
we see a lot of email addresses. We see some bad reviews. Let's delete them. We don't need them. So we can just alter data as we want. Since now we have admin rights, we are logged in as the admin. We can do just like, well, destroy everything. Actually, like, of course, you can guess this kind of routes and the kinds of URLs, but there are also like a couple of tools which are doing that for you. For instance, there's something called Deerbuster. Deerbuster, you can use. It's taking a couple of time. That's the reason why I'm not showing it like completely live. But that's a tool where you basically enter a target URL, and you can either provide a kind of list with the most common routes, like admin/admin/slash user. I don't know what if you think about routings and routes, what are your top 3 routes you always typing when you define routes in your Angular application?
Home, something like this, I don't know.
Home, right? Home,
Admin, yeah, it's also
admin,
quite common.
yeah.
Hmm.
And of
About.
course, I mean, about, of course, contact, impressum, like all this kind of stuff. Um, but luckily, we don't even have to think about that. There are already tons of text files which suggest this kind of most common routes. You
Mhm.
insert them inside the Steerbuster tool, and then it does its job. And basically, it takes some time. That's why, of course, as I said, I'm not showing the slide, but it takes some time. It just tries to call the API or the website with all the kind of routes we provided throughout the file. And then, like, of course, in the report, we see some kind of HTTP status codes. Some might have 500, some might have 404 not found, which is then okay. I don't have to dig into this route. Some of them might have 401, and 401 is unauthorized. And
Hmm.
this means that this route exists, but I don't have access to it. But this is already a good information that this route at least exists. So we not just have to steal a token from an admin, and then we can access this route as well. And we saw how easily it is. So of course, this kind of manual thing, like trying to guessing this kind of route, it can be so easily so easily automated, even with a brute force attack. I mean, you can just brute force it to run any kind of combination, and then it tries to enter a route with A and AA and AIA, then AB, ABBB, and so on, brute forcing, and you can run it throughout the whole night and go to sleep, and it does its job, which is scary. And then, of course, sometimes you also find some cool error messages. For example, if we know that the backend API we observed, it's always going to /rest, and let's just try to provoke an error. Well, Also, one of the worst things that could happen is that it leaks the whole information, basically. The whole information about what kind of server it's been using behind the scenes is expressed. The version number is 4.171. I'm actually not quite sure what the current version is, to be real honest. But now it's really easy. Like I could just ask ChatGPT or anything about exploits or CVEs from this kind of server version and, well, attack this kind of server as well. And I mean, we have a whole stack trace of it as well.
Yeah, that's nice. That gives us a lot of information.
Absolutely. And I mean, we should always handle errors really gracefully. Like, we should always take care that this doesn't happen. Maybe by implementing a global error handler inside our backend and maybe redirecting this to, or maybe, I mean, we could even, let me think about that. Yeah, I just thought about we can even maybe prevent this already in our Angular application. We could have something like a not found component, like matching all routes inside the not found component and displaying this instead, and so on and so forth. But basically, the backend never should reveal this kind of information. Coming to sensitive data exposures, like revealing sensitive information, you can do already so much inside and front-end application. Of course, usually you have, like as mentioned, a research phase where you're just playing around and trying to do so many things. And maybe you find a section like this one about, and what we could maybe also try to figure out if this website has some kind of download files, like maybe some markdown we download or and can read through it, or maybe something like that, that we know where the files basically are at in the web server. Of course, I already did this research phase for you, so if I click on this one, I get some legal information, like it's a markdown file, and yeah, it's just blah blah, just terms of use, legal information, log and y, not really something important. It's hard a little bit to read, but what we see over here is that it's not a markdown embedded or rendered inside the choose shop application. It actually comes directly from a directory /FTP. So what we could do also, removing maybe this legal thing over here and see if we have access to it. Apparently we have. I mean, otherwise I would have not shown that, but apparently we have. And well, look at that. We have a lot of things to see over here. What would be, if you would be a hacker, Manfred, what would be the most interesting file for you on this thing here?
Oh, I'm not sure. I'm not sure. Perhaps quarantine? I don't know. I don't know.
Yeah, I mean, this package JSON thing is like a backup file. Seems like with this backup file we can have a look in what kind of packages this whole thing is actually using. We have suspicious errors. So basically, it's like a log file maybe. So maybe there are some other errors. We have some incident report database. KDBX is like the MIME type, file type for databases.
Oh, okay.
I don't even know where I could start. We have coupons. So first of all, we can also just maybe look into another markdown file which has some confidential information. But okay, let's have a look into this package. I'm eager to know what kind of packages this application is using. So let's click on that. No, so the server doesn't deliver these kind of file because it's not a Markdown or PDF file. This is
That's
sad.
nice.
I mean, yeah, you say this is nice. I already say from a hacker perspective, this is
Uh,
sad. So,
yeah,
they
totally.
have some prevention measurement. This is so boring. So, okay, I need to maybe take another step. So, maybe I can try to trick the Express server that for the Express server, this kind of thing looks like a Markdown file. I mean, I could just add this extension over here. I can just maybe type .md and see what happens. Okay, yeah. Apparently, maybe the Express now handles this request to the file server, since it is .md, so the Express allows me to access this, tunnels it to the file server, but there, of course, now it said I don't have this kind of file. I don't have something called package.json.back.md. Okay, I must do it in a different way. So what a typical attack is to still try to trick the Express server to read my request as a Markdown file, but to make it vanished, this .md extension, when it got to the file server. This is something now really already a little bit deeper and a little bit more like file system and OS specific, or let's say C++ developers also know that. We have something like a null byte. A null byte tells the end of a string, basically, of text. The null byte is something, okay, now the end of the text is reached. This is exactly what we want here, don't we? So basically, we want to have this .md still be visible for the Express server, but as soon as it reaches the file server, we might want to insert here the null byte to tell the file server, this is the end of the string, ignore the .md, ignore everything behind it, this is the end of the string, it's fine, everything is fine, let's do that, just give me this file, I'm asking this file. And when we execute this, still something wrong. Okay, this is bad, but on some web browsers, older web browsers, it actually works, because the point here is now URL decoding. We need to URL decode this %sign, because the browser decodes it and makes something strange and different when it comes to the server. I mean, I don't know. I'm not so familiar with this kind of decodings, URL decodings. We have for white space, I guess we have %20, maybe. No. This is slashes. I guess a slash is %20. And we also have this kind of decodings for %sign itself. Just out of curiosity, would you know that?
No, I
Okay,
had to
then
look it
I'm
up in
calmed
the
down.
ASCII code or somewhere like this.
Oh, good. Then I'm really calmed down, because I would have no clue at all what kind of sign has which decoding. So there's a huge list, and there are already websites you can actually watch this. So, but if we take a look, it's actually %25. So %25 is the encoding for a %sign. Okay, let's see what happens. And there, the file system provides me that we can download this file.
Nice.
I download it, and let's watch it. Here is it. I mean, we could remove now this %00md, but it doesn't harm. So let's take a look. We have this kind of file. We have all the dependencies, and now we can even watch what kind of maybe version these dependencies are using. Here we have an SQLite. Oh, this scares me actually. But I think this is like, of course, the server needs it. This is also the package.json file for the server. So we can, it uses grunt, okay. So this is basically all the dependencies the choose shop is using, basically, which is yeah, could lead to some other following attacks. And this pattern we used here right now can be used for basically, well, any other files. I just need to add again this 2500% .md, and then we can take a look at this YAML file, which the suspicious error codes, and we can do this with all of these kind of things, which is, yeah, well, well, it is like it is.
Nice. I like it.
This is like already a little bit deeper, and of course you need to have a little bit more understanding about file systems and so on and so forth. But yes, so these are all kind of attacks you can use for the front end. I don't know if you still have time, I could show 2 attacks for maybe attacking an API.
Sure.
If you're up to that, because like one could say, yes, it's Angular, or like it's the front end, and the front end developers are not doing the right job. They're not encoding everything. But I mean, just to be sure, this attack here right now had nothing to do with the Angular application. It's the web server, which definitely needs to check and for all the kind of characters and signs that are inserted into. So in like coming through the front end. So it's not enough to check for the file type at the end. We need to see the string as such and encode everything, and we need to be so careful about that. Okay. If we have some time for
Yeah,
like
sure. We have time.
2 more attacks I really like to show, because you had also a great interview with Philip de Rick, which I really admire. He's like one of the RFC authors of OAuth and OpenID Connect, and he explained everything so great and well. And I want to show you maybe some attacks that could happen if you not validating your token correctly. So if you're not following the things Philip basically said as well, and like everything about authentication, authorization. I mean, I have here different kind of front end, but we're not really digging too much into the front end. We're just using it to figure out some network requests, basically. I'm also logged in. This is also an OWASP project. It's called Crappy, completely ridiculous API. I really like the name Crappy. So I didn't develop it. It's also an OWASP project, which basically is different like the tool shop. The tool shop exposes a lot of front-end security issues. Crappy, as the name says, it exposes a lot of API issues. So yes, let's start with the first one. And for instance, one of the common attacks is to try to access some data that, well, don't belong to me. And we see here, I have a couple requests to the dashboard, a request to an API user/dashboard. Okay, there's another request to /vehicle/vehicles, and it gives me, seems like it gives me some data to my own vehicle. Okay, so what I usually do is just you can also automate that, and I will maybe shortly show a tool how you can automate that. Just click around and try to get so many information about the API request as possible. One of these kind of API requests is, for instance, the location. So we see here the API request. It's a long URL, but let's see. It's like v2 vehicle / seems like an vehicle ID. So it's like an ID. It looks like in GUID. We usually do that basically, and then /location. So apparently this gives me the location, like the latitude and the longitude of my vehicle. Okay, let's figure out if I could do this request with another vehicle ID. I mean, I'm logged in, I have a token. We can figure out if this is basically, well, yeah, possible with another vehicle. So now we are doing our spy work. So where could we get another vehicle ID? So where here we could find maybe some information. So Manfred, when we look at these three tabs, could you imagine where we find maybe information about other users?
Community.
Community. Perfect. Aha, there is like a forum and we see three kind of posts. And we see already like a request that have been made. Let's dig into this. So we have three posts. Let's open the first one. Yes, created ad, author ID, comments, content ID, everything is fine. Now we have a nested object, an author object. Let's open this. And we see here is a vehicle ID. How the hell is this vehicle ID supposed to be here? This is one really common, like it's so common that we expose way too many information than the front end actually needs. To have this post here displays, I don't need a vehicle ID of this person, of this author. But sometimes we usually do like into string or to JSON, like we grabbing something from our MongoDB, having a JSON object, and yeah, forwarding forward to our front end. And then yes, all the information is inside basically, as well as the vehicle ID. This is basically called broken object property level authorization. Because maybe you've heard of that, there's not only the OWASP top 10, there's also something that's called OWASP API security top 10.
I think you told me in Berlin or somewhere around.
Exactly, because OWASP also focus this kind of top 10 list, not only like global, it also has specific kind of top 10 list. For instance, recently they released an OWASP top 10 for AI, basically for LLMs, how to protect yourself, like what are the common threats to AI models, which is of course another really scary thing. But let's one step after another, let's stay here at API security. And there's like one common thing, broken property level authorization, that I've been able to access properties which I should not be able to, like the vehicle ID. But not enough from that. Let's copy this vehicle ID. And let's figure out if I'm actually able to send a request with my access token to this vehicle ID. For that, I'm just using Postman, really straightforward. So there is like already a request. Here's my vehicle ID inside. So if I send it, I get the information about my vehicle. Basically, we already seen this. But now I add another vehicle ID. Let's do that. I click on send and awesome. Apparently the backend just checks if a user is logged in, but not if the user is authorized to get this object. And well, I don't know about you, but I could do a lot of things with this latitude and longitude. I can just enter this information into Google Maps and write a nice email to the email address of this person and maybe blackmail him or her like really badly. I mean, I would not do that, of course not. I would not do that, but I could do that if I want to get maybe some money from this person. So I could write, hey, I know where your car is at, or something like that, and I know where you live. Some quote from some scary horror movies, but yes, this is really broken. It's called broken object level authorization, and because sometimes backend API just check if someone is authenticated, but not really checking the authorization on that. It's terrifying as well, basically. My last attack I like to show is about actually manipulating an JWT. For that, I want to take a look into some kind of API request that looks like, for instance, a dashboard. The dashboard API request reveals some information about myself, but I don't find any kind of user ID or any kind of information that tells the backend API, get me please the user data, the dashboard data for this kind of user. So I come to the conclusion that the backend API must retrieve this kind of information out of the JWT token. I'm pretty sure, and you should, if not, you watch the interview with Philip de Rick, and maybe he explained the kind of claims you have inside an access token. And inside the access token, there's, for instance, a claim which tells to whom the token belongs to. So this claim must give the API the information that, yes, please give information to this kind of subject, to this user. Okay, so we shortly take a look again over here. We have our user dashboard. I send, everything is fine. Like this is my token. This is really my token. I want to manipulate this token now. I mean, we can find it. I mean, I showed how you can steal the token. You can just do that. And then basically, let me shortly copy this token over here. It's like a huge, huge token. And then we just use a great, great tool. It's called JWT tool. With the JWT tool, you can insert a token. And then you get some information about the token, the claims basically. And JWT has three parts: the header, which gives information about which kind of algorithm is been used for the signature. Every token should have a signature. And of course, these kind of claims, the subject. So let me explain two attacks usually someone can do. And one of the attack I will actually execute, I could tamper this token with the help of the JWT tool. So the first attack could be to change the algorithm that has been used for creating the signature of the token. Okay, so I tell now that it should be set to none. That means as soon as a token gets to the backend and it tries to maybe validate the token, it sees, well, the token doesn't have a signature because apparently there is no algorithm for the signature provided. So yes, everything is fine because everything is fine because even though there is actually a signature, the backend will ignore it because I set the algorithm to none. Perfect. This is this is a lot of backend APIs are doing that. And how you easily could solve this is to just having a whitelist of allowed algorithms that are inserted here. And as soon as a token, a JWT, has a none, you immediately reject it. There should never be unsigned JWTs in your backend, never. And yes, so with the JWT tool, I got now this kind of token, which basically, yes, is now the token with the non-algorithm. But let me have another example. Now we're not changing the algorithm, but I want to change the subject. The subject is an email address. Okay. Where do we get an email? Do you remember where we could get an email address out from? When we go back here.
You mean in the token or here in the application?
In the application, I just want to have any kind of other email address.
Oh yeah, so in the community section, I guess.
Absolutely right. So, because here we already saw that the author reveals so many things, we can just use anything out of that. So, let's take this one, this
Hmm.
email address, and yeah, yes. Now let's change it to this email address, and I don't want to change anything else. And here we have a beautiful token. And if you maybe just watch it once again, we see that it's basically the same token like before, but I just changed the subject now over here.
Hmm.
Okay, perfectly. So let me shortly copy this token over here. And let's use this one, this token over here. I hope I copied it correctly.
Do we need
So
to set the algorithm to none? Because I
in
think
this,
this one is signed.
in this case, not, because what I try to figure out, because you're thinking correctly, definitely, because um, as soon as I change something, apparently um, the backend should check the signature and tell, hey, you manipulated the payload, go away and reject the token. But this is exactly what I'm trying to figure out. If the
Ah, yeah.
backend really actually checks the signature, because scarily, I don't know if scarily is even a word, but let's assume it is a word, scarily. There's so many backend APIs which are not doing this, checking the
Oh, wow.
signature.
Wow.
So, I mean, yes, I mean, we could imagine where this is going to. So let me copy this. I hope I copied the correct one. So when it comes to authorization, we right now don't want to inherit it. So we want to insert my own bearer token. I just manipulated. And let's see. Apparently, the backend doesn't check the signature and just gives me the whole user information. I mean, a couple of these kind of information I already got just by requesting the community section, but well, we can just easily do that, because yes, the backend doesn't check the signature. Having that said, I can't emphasize enough that we need to check our tokens in the backend. Try to not implement that on your own, like creating the
Hmm.
token, because I mean, of course, one could tell me, yes, Martina, I'm checking the signature and everything is fine. But the thing is, the how the signature is created is also a really important part in this whole scenario. If the key is really weak, or if the algorithm we've been using to create the signature is maybe just a checksum or just something really easily breakable, then the signature can be easily be broken. And
Hmm.
as soon as someone is able to actually break the signature and create their own GWTs with exactly the same signature algorithm and the exactly same key, the backend could never ever figure out. The backend is completely lost, because for the backend it's a valid signature. It completely belongs to the payload. The payload isn't changed. The backend doesn't have any kind of chance to figure this out by just checking the signature. It must have additional checks. For instance, it could be the case that for this subject, the identity provider never ever created a token. This could be an additional check, which most of the backend packages from common identity providers providing also like these kind of checks. So I highly recommend, don't do this at home at your own. Use any kind of identity provider. You can use your own, like Keycloak, for instance, if you want to host this on your own. Identity as a service, like, of course, what out there. I don't want to have like advertising any kind of identity provider in special, but there are so many out there which are doing a great job that you don't have to think about that.
Hmm.
Yes, having said that, that's actually all I want to show for today, I don't know about you, Manfred, but what were your favorite attacks basically? Or what was the most eye-opening or scariest for you?
Well, I did not know about this stack with the, zero, because of C code that is assuming that the string ends with zero. So I have not seen this before, but I really like it. So
Yeah,
I
absolutely.
can't wait to try it out in the web. No, I guess I should not.
Yes, of course. This is always like, maybe I should have mentioned it in the beginning. Of course, this is all considered as ethical hacking. Don't do
Hmm.
anything I showed on some web page out there. Um, Other on your own, you can try to do it on your own to maybe figure out some things. But yeah, of course, not go to any kind of web page and just try to steal a token and whatnot. It could lead to some bad things for yourself, of course, because maybe they track this and then it could be scary for you, actually. So
Hmm.
this had just the purpose to make you aware what could happen if you're not validate your JavaScript enough, if your backend API exposes too many information, if you don't care about your file systems, and so on and so forth. And I hope this was a little bit educating and you got kind of a feeling what, well, our security workshops are all about, basically.
That's really awesome. Yeah, for me it was both. It was educating, but also entertaining. And I think this is what a good workshop should be because it keeps you listening. And you already mentioned it. You have this security workshop. I will link it below. Can you tell us a bit what you are doing in this workshop and what we can learn there?
Yeah, of course. So basically, this Angular security workshop, I do show a lot of those attacks I showed right now, like JavaScript injection and cross-site request forgery. I already mentioned that, for instance, Angular has a built-in mechanism for CSRF and whatnot. I showed already something like the content security policy header. And basically, I will show a lot of things that could go wrong when it comes to secure development in Angular, and of course providing many recommendation and a lot of techniques where Angular can be developed definitely more securely. Additionally, of course, also how you can bring your Angular application a little bit to a more secure level, also when it comes to maybe stealing the token out of the local storage. We will integrate, for instance, an identity provider, and I will also talk a little bit about identity OAuth 2.0 and 2.1 and OpenID Connect, and we will integrate it together. We will learn about all the things that could go wrong when you're dealing with this kind of JWT, and of course also telling you with a lot of practical tasks and solutions for those, yeah, how you can protect your Angular application.
Oh, that sounds awesome. So if you're interested into this, click the link below. And if you're not interested, click the link even though, because you really need this knowledge if you have a mission critical application. Yeah, cool. So thanks, Martina, for your time. That
Thanks
was
for the
really
invitation.
awesome and very, very interesting. And yeah, see you around.
Yeah, thank you so much and see you.
Bye bye.
Bye.